Hello everyone, welcome back to channel. I am Nikhil Kumar. In the last video, we created files, searched inside them, edited with Vim, and today we are going one level deeper. But before that, let me ask you something. Have you ever mounted a volume in Kubernetes? Everything looked correct, but pod still threw this. Frustrating, right? Today that confusion ends. We are going to understand users and groups, what is UID and the GID, how to change permissions of the file and the owner of the files in the folder, why pod often run as non-root, and finally, what is sudo and how to use the sudo access. By the end of this video, permission issues won't scare you because Linux finally makes sense both inside the server and Kubernetes. Before we start, let me quickly recap the last video task. And I will explain while I type so you understand every command. So first of all, we need to create a workspace. So for that, we can use a mkdir command, mkdir and the directory name, that is project. So now we need to go inside this particular directory. So we can use cd command. And I'm inside the project directory now. Now I will create a file for the demonstration. So for that, I'm going to use a touch command. So it will create an empty file in this particular location. So here it created the three files for us: app.txt, config.txt and db.txt. And these are just an empty file because with touch we can create a empty files. Now let's put some data in these files. So we can use a echo command here. And if I run the same command again, we can see the content got updated into this. Now each file has a useful content to test on. If we want to find where the DB appears, so we can use a grep command. So grep DB, that is a text, and I'm going to do the recursive search here and dot. So here the DB text got found under the db.txt file, and we can locate content without opening the file here. Now if we want to locate some file, so we can use a find command. So find dot hyphen name and config.conf. There's a typo here. And we can see the config.conf file got found by the find command. And these skills can save hours in the production scenario when you are looking or searching for some file or the text information. Similarly, if you want to check the disk size, so we can use du -sh and dot. So we can see the usage of the current folder, and it's very useful when debugging the volume space issue. So this folder will become our playground today. So this is a task which I gave in my previous video. I'm going to build the next concept on the top of this only. We will break permissions here, fix them, and fully understand how Linux security works. So to fix the permissions, we must first understand who are we. Let's start with the user here. In Linux, everything you do is done as a user. Even if you never think about it, Linux knows exactly who you are. So let's confirm which user we are currently logged in as. So for that, we have a command in Linux, that is whoami, who am I. So this prints our username from which we are logged in right now. So I'm logged in as a root user here. Now if we want to go deeper about that particular user, we can use a id command here. So if I run here id command, so the id command gives your UID, primary group, and all the groups you belong to. So let me explain you. The UID means your numerical identity. GID means your primary group number, and the groups is like your part of which group. And this is the SE Linux context of this particular user. Username is just to have one label, but UID is what Linux truly recognizes. Even containers in Kubernetes runs as a UIDs internally. Users are individual, but access is usually shared for that. For that, we need a group. A group is like a team. Instead of giving permissions to users one by one, Linux assigns access to a group. So let's see which groups I belong to. For that, we can use a groups command. So this tells us which team the current user is part of. So here I can see that is a root. So this root user is a part of a root group only. So if I want to test something for the another user, so for that I can use id space Nikhil. And we can see the information got changed from the root user. So here the UID of the Nikhil user is 1001 and the group ID is 1006, and it's a part of a Nikhil user. Now the groups and the users are clear. It's time to see how files allow or block access. So let's list the files with details so we see ownership and the permissions clearly. So for that, in the last video we saw ls-l command. which shows the detailed view of the files in the current working directory. So here it shows a different set of information here. First of all, it shows the file name, the date and the time and the size of this particular file, and the user and the group information. So all these files are owned by the root user and the root group only. And here we can see there are some text written over there with hyphens. These are the permissions. The first three is for the others permission. Second is for the group permissions. And third is for the owner permission. And each is having the read, write and execute permission. So here we can see the owner is having a read, write permission. Group is having the read permission. And other user is also having a read permission here. Now let's take an example here and change the permission of one of this file. For that we have a command that is chmod. So for that we need to understand three key things here. So we have a three set of permissions here. One is for the owner, another is for the groups, and third is for the others. So for that we have a three types of permissions as well, like read, write and execute. First is like we need to give a read access. Second, if we want to give a write access. And third is we need to give a execute access. If we have some script and if we want to execute that, so we can give that access to that particular file as well. So we have a number coding for each of these access as well. So if we want to give some user an access to read only, so we can use a 4 over there. And if you want to give some user an write access, so we can use a 2 number over there. And if you want to give a execute access, so we can give a number 1. So how to use these numbers in the chmod command? Just remember these three things, like what is the read, what is the write and what is the execute, and you can able to give an access to any user with a chmod command. So let's update the access of this particular file. So let me update it, chmod. So I'm going to update the access of this particular file. So I'm going to use 664 and the file name. So let me explain you. This is the command to change the permission. 6 means read and write. 4 plus 2 is 6. The similar fashion, whatever it's updated here, we will follow the same here as well. This is for the owner, this is for the group, and last is for the other users. So to owner I gave a 6, that is read write. For group as well I am giving a read write, that is 6. But for the other users I am giving a 4, that is read only. And if I hit enter, the command got executed successfully. And if I run the same command again, and we can see the access got updated to read write. With the help of chmod command, we can change the permission of any files or any folder, and we can secure it from any other user or any unauthorized user as well. And this is very useful when you are working with a multi-shared environment where multiple user accesses the same system. So to avoid the unauthorized access, you can change the permission of that particular file. Your data will be safe. Now if you want to change who owns the file, so for that we have a command as well, that is a chown. And let me clear out the screen first. So chown is a command to change the owner of the file. So this command can be used to change the owner or a group of each file. Now let me update this very quickly. So we have 3 files here, and we can see all the files are owned by the root user. Let me change this file owner to the Nikhil user. So for that what we can do, chown Nikhil and the file name, that is config.conf, and the owner got updated. If I run the same command again, now we can see the config.conf file is being owned by the Nikhil instead of the root user. But I didn't touch the group remains the same. Only the user I changed. So using this command we can change the user as well as the group information. This is important because many beginners think permission just read, write, execute. But ownership decide who those permissions apply to. Right now only config.conf is mine, but app.txt and the db.txt still belong to the root user. And that's the key difference. So even though all these 3 files are in the same folder, Linux does not treat them equally. It looks at the ownership first and then checks the permission. Think of it like this: if I own my notebook, I can write freely. But if someone else owns the notebook, I need permission from the owner. Now to really understand this, let's create a real world scenario here. Let's take a app.txt file I created. I can see it, I can read it, but what if I lose the ownership of it? Let's break it intentionally and feel what happens when we try to write without permission. So this particular file is owned by the root user. Let me log in with the different user here. And to switch to the another user, we can use the su command with the username. Now I am logged in with the Nikhil user. If I do ls-l layer, we can see the same data which is being shown by the root user. But this file is owned by me. So let me update this. So vi config.conf, and here I'm just adding the random text testing, and I'm able to save and exit this file. And the same content got updated here as well. Now let's try to update one of these files, that app.txt or db.txt. So I'm going to update the app.txt file. And if I try to update something, here I can see I got a warning that changing a read-only file. And if I try to save and exit this file, I'm not able to save this file because it's having a read-only permission for the Nikhil user. And if I override this, and if I do cat here, so I'm not able to edit this file at all because of the permissions only. Because this particular file is owned by the root user, and the root user is having the permission to read and write, but other user is only having a read-only permission. This is exactly how Linux thinks. If you don't own thing, you cannot modify it. Linux is just protecting the file, and to write again, we need to change the permissions or update the ownership of that file. So let me come out of the Nikhil user, and let me change the ownership of this particular file as well to Nikhil and app.txt. Now the ownership got updated, and we can see both the files is owned by the Nikhil user. If I use that su command again and switch to Nikhil user, and if I run ls-l here, and if I try to update this file, and this time it will allow me to do the modification, and it got saved because now I am the owner of this file. Now that permission and ownerships are clear, let's look at one more thing we use every day, that is sudo. Think of sudo as a shortcut to run a command with admin power whenever we require. So sudo simply means run this one command with root level access, just a temporary switch, not a permanent one. So if I run whoami here, let me log in with the Nikhil user first. If I run ID here, we can see the Nikhil user information here, and if I run whoami, we can see the user is Nikhil. Right now I am a normal user, I don't have any full power, just my own permission I am having. Now let's check what sudo gives to us. So for that we have a command, that is sudo -l. It tells what this user is allowed to run with sudo. And here we can see all the commands can be used or run by this particular Nikhil user, and it will not ask for the password. Don't worry if you are not able to understand this line. I am going to cover the sudo and the sudoers file in the next video in very much detail. So in our system, some files or commands are protected, and you can't edit the system or configs or restart the service as a normal user. But sudo lets you do exactly that whenever we need it. So if I try to update or edit this file, that is /etc/host file, I won't be able to edit this because it's in the read only mode. So if I try to save and exit, I'm not able to save and exit this. So if I do it forcefully as well, it's not allowing me to do that. So let me say I exit from this, and instead of normal user, if I use sudo at the starting of this command, so this particular file will be opened as a root user. So if I update something here, and here testing sudo, and if I save and exit, and I can see the content got updated. And if I cat this file, we can see the content got updated here. And if I run the whoami with the sudo user, we can see it shows the root user over there. So sudo whoami, here we can see the root user. But if I run it without sudo, it will only show the normal user here, that is Nikhil. Similarly, if I run sudo with ID, so we can see it shows the root user information here, not the normal or the logged in user information here. Now if you notice the difference, without sudo, Linux blocks us. When I tried to update the etc host file, it blocked me. But when I tried the sudo, it's allowed me to update this file because we are running with the admin power, but only for that particular file editing or that particular command only. So now we understand users, groups, permissions, and how sudo helps when we need an admin access. That's the foundation you will use everywhere, inside servers, inside your container, or inside your Kubernetes cluster. And that brings us to the end of one of the most important Linux concepts for DevOps. You now understand how users, groups, permissions, and sudo actually control access in Linux. Now that permission makes sense, we are ready for our big step. Video 4 is all about processes, services, and system D. If you found this helpful, hit like, share it with your friends, subscribe and hit the bell icon so you don't miss the video 4 when it drops. Thanks for watching. I will see you in the next one.